Magnets are an invisible yet essential force powering the modern world. From the tiny vibrations in electric toothbrushes to the massive generators in power plants, magnets play a crucial role in countless technologies. They are the silent workhorses behind electric motors, data storage, medical imaging, and renewable energy systems. Despite their widespread use, traditional magnets have always had limitations, especially when it comes to generating strong, stable magnetic fields. For decades, scientists and inventors have dreamed of harnessing magnets to create free energy, machines that generate more power than they consume. Yet, these dreams have remained out of reach, held back by the weakness of available magnetic materials. Now, a groundbreaking advancement by Nyron Magnetics could change everything. Their newly developed supermagnets are up to 10 times stronger than conventional rare earth magnets. This leap in magnetic strength could finally make free energy devices a practical reality. Imagine a world where energy is no longer tied to fossil fuels or limited by grid infrastructure. A world where small, efficient machines generate clean, limitless power. This is the future that Nyron Magnetics innovation could make possible. To understand the significance of this breakthrough, we must first examine the role magnets play in today's technology. Every electric motor, whether in a household appliance or an electric car, relies on magnets to convert electrical energy into motion. Generators, which produce electricity from mechanical energy, also depend on magnetic fields. Even cutting-edge technologies like magnetic levitation trains and advanced medical MRI machines require powerful magnets. Yet, despite their importance, traditional magnets have always had a ceiling in terms of strength and efficiency. Rare earth magnets made from elements like neodymium have been the gold standard for decades. While they are stronger than older ferrite magnets, they still fall short of what free energy devices require. Many free energy concepts, such as the Newman Motor, Johnson Motor, and Bedini Motor, have struggled due to these limitations. These machines rely on permanent magnets to generate motion and electricity without external power input. However, the magnets available until now simply weren't strong enough to make these systems truly efficient. Nyron Magnetics' breakthrough changes this equation entirely. Their supermagnets are made from a proprietary alloy of neodymium, iron, and boron engineered for maximum magnetic density. The key lies in their advanced manufacturing process, which aligns magnetic domains more precisely than ever before. This results in a magnet that is not only smaller and lighter, but exponentially more powerful. With these supermagnets, free energy devices could finally overcome their biggest hurdle: insufficient magnetic strength. Take the Newman Motor, for example, a design that has fascinated inventors since the 1980s. The motor uses permanent magnets to create rotational motion, theoretically generating more energy than it consumes. Yet, in practice, traditional magnets couldn't provide enough force to make the system self-sustaining. By replacing these magnets with Nyron's supermagnets, the Newman motor could achieve the torque and efficiency needed to function as intended. Similarly, the Johnson motor, another promising free energy concept, could see dramatic improvements. This motor, which relies on magnetic interactions to produce motion without external power, has always been limited by magnet strength. Nyron's supermagnets could enhance its rotational speed and power output, making it a viable energy source. The Bedini motor, known for its pulsed electromagnetic design, could also benefit immensely. Traditional magnets restricted its efficiency, but supermagnets could amplify its energy generation capabilities. Even more ambitious projects like the Magnecoaster, a magnetic perpetual motion concept, could become feasible. With stronger magnets, the device could maintain continuous motion, potentially generating usable electricity. Electric vehicles could become lighter and more efficient with smaller, more powerful motors. Wind turbines could generate more electricity with reduced mechanical resistance. Space exploration could benefit from compact, high-efficiency power systems for long-duration missions. Of course, challenges remain: skepticism, engineering hurdles, and the need for further testing. But the potential is undeniable. Nyron Magnetics has opened a door that could lead to a new era of energy independence. The dream of free energy, once dismissed as impossible, may now be within reach. As research and development continue, we may soon witness the rise of machines that defy conventional energy limitations. The magnetic revolution has begun, and it could change the world forever. The second major aspect of this breakthrough lies in its broader implications for science and industry.
While true perpetual motion remains impossible due to the laws of thermodynamics, free energy devices aim to extract energy from ambient sources. Magnets, with their ability to generate force without direct contact, have always been central to these designs. Yet, until now, their limitations have kept free energy machines in the realm of theory.
Nyron supermagnets could bridge the gap between theory and practical application. By dramatically increasing magnetic field strength, these magnets enable devices to operate with unprecedented efficiency. This could lead to machines that harness energy from magnetic fields, mechanical vibrations, or even thermal gradients. One of the most exciting possibilities is the integration of supermagnets into renewable energy systems. Solar and wind power, while clean, are intermittent, dependent on weather conditions. Free energy devices, if perfected, could provide continuous supplemental power. Imagine a hybrid system where solar panels generate electricity during the day, while a magnetic free energy device takes over at night. Such a system could make off-grid living fully sustainable. Another promising application is in energy storage. Current battery technologies rely on chemical reactions, which degrade over time.
Magnetic energy storage, using supermagnets, could offer a longer-lasting alternative. By storing energy in the form of magnetic potential, these systems could charge and discharge indefinitely without wear. The transportation sector could also undergo a radical transformation. Electric vehicles still face range limitations due to battery capacity. A free energy-assisted motor, powered by supermagnets, could extend range significantly. Even if not fully self-sustaining, such a system could reduce reliance on charging infrastructure. In aerospace, where weight and efficiency are critical, supermagnets could enable breakthroughs.
Magnetic propulsion systems, currently experimental, could become practical with stronger magnets. This could lead to faster, more fuel-efficient aircraft, or even new forms of space propulsion. The medical field, too, could benefit. MRI machines require incredibly strong magnets to produce detailed images. Nyron supermagnets could make these machines more compact and affordable. Portable MRI units could become a reality, bringing advanced diagnostics to remote areas. Beyond practical applications, this breakthrough challenges our understanding of physics. For years, free energy concepts were dismissed as pseudoscience. But with tangible advances in magnet technology, these ideas must be re-examined. Scientists may need to revisit old experiments with new tools, uncovering previously overlooked principles. Of course, skepticism is healthy. Extraordinary claims require extraordinary evidence, but the potential rewards justify rigorous investigation.
If even a fraction of these possibilities materialize, the impact would be profound. Energy poverty could be alleviated as communities gain access to self-sustaining power sources. Carbon emissions could plummet as fossil fuels are phased out in favor of clean alternatives. Technological innovation could accelerate as energy constraints are lifted.
Nyron Magnetics supermagnets represent more than just an engineering feat. They symbolize a shift in what we believe is possible. The journey from laboratory discovery to real-world application will take time, but the foundation has been laid. The magnetic revolution is not just about stronger magnets, it's about reimagining the future of energy. As research progresses, we may witness the dawn of a new energy paradigm, one where power is no longer scarce, but abundant and accessible to all. the age of free energy may finally be within our grasp.